right, let's talk now about two special relationships that sometimes lines have. Okay, now in general, not every pair of lines is parallel or perpendicular, um, but in some cases, we do have that relationship. Two lines are considered parallel if they run side by side and stay the same distance away from each other all the time. They never get any closer, they never get any farther away. So things like railroad tracks or the edges of your sidewalk. Um, in order for that to happen, the slopes of these lines have to be the same. Every time one of the lines rises, the other one would have to rise that same amount. Every time one of them runs, the other one would have to run that same amount if they're going to stay the same distance apart all the time. If two lines are going to be perpendicular, then they intersect, but they intersect in a special way. Okay, these two lines here are not perpendicular. Okay. Perpendicular specifically means that when they intersect at a right angle or a 90-degree angle. Why won't that go away? Okay. Now, in order for that to happen, their slopes have a special relationship. Okay. Notice that between these two lines that I have drawn up here, really the only thing we can say about the slope M1 of this line is that it's a positive number. Okay, and the slope M2, as that line goes down from left to right, is a negative number. So we know that those slopes are going to have opposite signs. Okay. The rest of the relationship is that they are also reciprocals. Okay. So perpendicular lines, if you take one slope, you have to both flip it upside down and change its sign, and then you'll get the other slope. Okay. Some authors will also point out, and some students find this helpful to think about, is if you multiply the two slopes together, you get the number -1 all the time, okay, if those lines are perpendicular. So if I'm looking at two lines with my eyes, I might be able to determine whether I think they're parallel or perpendicular, but looking with our eyes isn't good enough to be able to make that determination. We have to be able to algebraically show that, yes, those lines are parallel, or yes, they're perpendicular, or no, they're not. Okay. So the only thing that we look at in order to do that is we look at the slopes of their lines. Okay. Maybe I have y equals 2x plus 1. Maybe I have y equals -2x plus 3. The slope of that top line is 2. The slope of that bottom line is -2. Let's call this line A and this one line B. Okay. Now notice that A and B, if they were parallel, this would be the exact same number. Okay. Since it's not the exact same number, these two lines are not parallel. If I'm checking to determine whether or not they're perpendicular, okay, they have to have two pieces, both pieces of this relationship. One is that they have to have opposite signs. Okay, this one's a positive slope, that one's a negative slope, so that part checks out. The other piece, though, is that one has to be the reciprocal of the other. Reciprocal means I have to flip it upside down. So if I flip the number 2 upside down, I get 1/2. Okay. If I wanted to be perpendicular to line A, my slope would have to be -1/2. Okay, here I have -2/1, which means lines A and B are not perpendicular either. Okay, most lines that we draw in space have neither relationship. Okay, it's not expected that any two lines have to be one or the other. Most of them are neither. Okay. If I have line C, let's say we have 3 x minus 6y equals 10. Okay, I want to determine whether or not line C has a relationship with one of these two lines, A or B. If I want to figure out if it's parallel to some other line or perpendicular to some other line, then I need to know its slope. The best way for me to find the slope of this line is to put it in slope-intercept form. So I will move the x term to the other side, then I'll divide everything, every piece by -6. -3 divided by -6 is +1/2, and 10 over -6 is -5/3. Now understand the only piece of this equation that we need is the slope of that line, which is the number in front of the x. If I look at the slope of line C, it is not the same as the slope of A or B. It's not 2, it is not -2, it's equal to 1/2. So C is not parallel to anything I have on the board. But notice if I take a -2 and I flip it upside down and I make it positive, then I have a +1/2, which means line B, and I'm not pointing at the 5/3 here, I'm just pointing at that line in general. Line B and line C are perpendicular to each other. None of the lines that I have up there on the board are parallel to any of the others. Lines B and C, if I were to graph them, they would make a 90-degree angle. If I take 1/2 and flip it upside down, I get 2 over 1. I change its sign, I have -2. That's the slope of B. Okay, if I start with -2 over 1, change the sign and flip it upside down, I get +1/2, which is the slope of C. Okay, that tells me they're perpendicular. Get a hold of me if you have questions about parallel and perpendicular, please.